Hi, my name is Abigail Maxwell.
My name is Alicia Young.
My name is Vanessa Robinson.
And I am Marie Barrazo. We are doing a presentation on geometric transformations.
So the objective for this section is, by the end of this lesson, students will be able to find a reflected image and write a rule for reflection algebraically using coordinates, define a reflection as a transformation across a line of reflection with any given properties, and perform reflections on and off a coordinate grid, translate a figure, and represent the transformation algebraically using coordinates, find the image of each figure after a sequence of transformation, prove that a translation is a composition of two reflections, rotate a figure and represent the transformation algebraically using coordinates, prove that a rotation can be written as a sequence of transformations, specify a sequence of transformation that will carry a given figure onto another, use geometric descriptions of rigid motions to transform figures, identify a sequence of translations, rotation, and or reflection that maps a given figure onto itself, predict the effect of a given rigid motion on a figure, determine symmetries of reflection, symmetries of rotation, and symmetries of translation of a geometric figure, dilate figure on and off the coordinate plane, understand how distance and length in a dilation are related to the scale factor and center of dilation, understand that two figures are similar if there is a similarity transformation that maps one figure onto the other, identify the coordinates of an image under a similarity transformation. What is a transformation? A transformation is a rule applied to a geometric figure which usually result in the figure being moved or changed in some way. In a transformation, the original figure is called the pre-image, while the resulting figure after the transformation is called the image. There are four types of transformations taught in geometry. There are translation, rotation, reflection, and dilation.
So, as stated, there are four types of transformations. The rotation, when you look at rotation, the object rotates or turns in a pre-image around an axis. There's no change in shape or size of the figure. The reflection is a flip of the image, of the pre-image, and produces a mirror image of it. There's no change in size or shape or orientation. This translation, it slides or moves in the same direction as the pre-image, and no change in size or shape or changes in the direction of the shape. And the dilation is a stretch or shrink, which expands or contracts the shape. For example, a rotation. Simply looking at a rotation, in this case, if you notice point C, in point C, I rotated the object and I moved it over. So I rotated the object. So it could have the area is obviously a way to check it in GeoGebra. There are multiple ways of checking this, and it'll rotate around that particular point.
So as Marie just stated, rotation is a transformation that changes the position of a figure by moving it around a fixed point, either right, clockwise, or to the left, counterclockwise. It is described by its center of rotation and angle of rotation. So if you're going to rotate a figure, you need to know two things: at what angle you're rotating it and in what direction, clockwise or counterclockwise. Now, any rotation can be described by two reflections whose line of reflection meet at the center of rotation at half the angle of rotation. So the rules, the coordinate notation rules for a rotation, these are the counterclockwise rules. If you're going to rotate a figure 90 degree counterclockwise around the origin, the pre-image xy will become negative yx. If you're going to rotate a figure 180 degrees around the origin, the point pre-image x comma y becomes negative x comma negative y. and if you're going to rotate a figure 270 degrees counterclockwise around the origin, the pre-image x comma y will become y comma negative x. Now, these are the counterclockwise rules. To get the clockwise rule, we know that a 90-degree counterclockwise will be the same as a 270 degrees clockwise. So that rules apply to the clockwise rotation. So 90-degree counterclockwise rotation is the same as a 270 degrees clockwise, so that rules apply. A 180-degree counterclockwise rotation is the same as 180-degree clockwise, so there's no difference between the rules. 270-degree counterclockwise rotation is the same as a 90-degree clockwise rotation, so the same rules applies.
The next transformation is reflection. So as you can see in GeoGebra, by hitting this particular symbol, we get a reflection over a line. So if you notice, I have the original value here of ABC. The reflection ABC is also on this side of the slide. It actually does it for you. The coordinates will change accordingly. And if you notice, these match, C matches to C prime, A matches to A prime, and B matches to B prime in the same number of units.
A reflection, as Marie just said, is a transformation which flips the figure across a line called a line of reflection. Now, each point and its image are the same distance from the line of reflection. Matter of fact, the line of reflection and the segment connecting the pre-image and the image are perpendicular bisectors. Now, the rules, I spell reflection wrong here. You didn't see that. The reflection rules are, if you're going to reflect across the x-axis, the hint is you change y. So if the pre-image was x comma y, the image would be x comma negative y. If you're going to reflect across the y-axis, the hint is you change x. You change the sign for x. So if the pre-image was x comma y, the image would be negative x comma y. If you're going to reflect across the diagonal line y equals x, the hint is you swap x and y. So if the pre-image was x comma y, the image will be y comma x. And if you reflect across the negative diagonal line, y equals negative x, the hint is you swap and change x and y. So if the pre-image was x comma y, the image will be negative y comma negative x.
The next transformation is a translation. As you can see here, again in GeoGebra, this figure ABC is translated over the array U, and it's translated over A prime, B prime, C prime. A corresponds to A, B corresponds to B prime, and C corresponds to C prime. So that is the rule of thumb of a translation.
As Marie just said, a translation is a transformation which slides all points of the pre-image in the same distance and in the same direction. So also a translation is a composition of two reflection. The rule for a translation is the pre-image x comma y. To get the image, you're going to add h and k to x and y, where h is your horizontal shift and k is your vertical shift.
And the last transformation is a dilation. In the dilation, you notice this large figure here, ABC. This has been dilated to A prime, B prime, C prime. If basically you select the object and you give the ratio 1/2, and so 5:10, that becomes a smaller dilation.
A dilation, as Marie just stated, is a transformation that changes the size of a figure, but not the shape. So the pre-image and the image are similar. It stretches or shrinks the original figure by the scale factor, which is K. Now, the center of dilation is a fixed point in the plane about which all the points are expanded or contracted. The rule for a dilation centered at 0, 0, because if it's not centered at 0, 0, we have to do something else. But the rule, if the center of dilation is the origin and the scale factor is K, is the pre-image x comma y gets multiplied by the scale factor K. Now, if the scale factor is a number between 0 and 1, then the dilation would be a reduction, and the center of dilation If the scale factor is between 0 and 1, the image gets smaller and closer to the center of dilation. That means it's a reduction. If the scale factor is greater than 1, then the image gets larger and further away from the center of dilation.
The first practice activity the students will be doing is the shape game. So basically what the students will do is when they go to the game, so basically what they'll do is when they go to the game, will reinforce what a translation, a rotation, and a reflection is, and it'll give them key terms like to remember what those items are. And then the game will start. The students will have 6 items that they'll show different transitions for that item, and they'll tell the students select all of the translations. Now, if the student selects the translation that isn't transition, it'll make a sound and it'll tell them this is a whichever translation it is, whichever transformation it is. And then that way the student will know, okay, so I thought this was this one, but it's not, it's really this other one. And so it'll keep reinforcing. If the student selects the right one, it'll tell them, okay, if they selected all of the shapes that it is on that image, then it'll tell them, okay, go to the next question. And for every wrong answer that they select, it does navigate them to what that shape is, so the students will know and practice the activity to get more familiarized with what happens with each transformation. The next activity the students are going to do is a hands-on activities. They're going to use this worksheet to create they're going to put a shape into quadrant 2, and then they're going to start doing the rotation and reflection so they can get a hands-on activity, further pedagogical knowledge to know what's a reflection, what's a rotation, and they'll be able to self-learn, self-direct. And them choosing their own shape also gives them the opportunity to be a little different, but also still get the same information that's needed. This video is to help the students do the reflection portion of the hands-on activity. It's a short video. It's less than 5 minutes for the whole video. The students can pause it, do that part, then unpause it, or go back to it, or watch the whole thing and then try to do it the whole thing without watching it. So it's different ways the students can do this activity, but it's a resource for the students that need self-guidance through every step. The same thing with the rotation. The students will do as the video tells them to see their chosen shape in a rotated form, so that way they can get a visual and get a further deeper understanding of what the pre-image and the image would look like in whichever angle, clockwise or counterclockwise, for that specific shape. And then the students will go to GeoGebra. This is one of the activities that they will work on. So with this activity, it's different questions. Once the students change the shape, if the shape is wrong, if it's not in the right spot, it will tell them it's not correct, try again. After the second attempt, it will give the student a hint to do it a third time. And if it's still not right, then it'll show the student what that image should have looked like. So that way it's reinforcing the transformation knowledge that the students will be getting.
All right, and so now we'll head over to the GeoGebra book so that we can see what some of the other examples that the students have access to will be. And also we'll come back and discuss the formative assessments. So from the GeoGebra book, we have a page called Examples 1, which really gives the student a really good visual on what the different types of transformations are, and also the combination the combination of transformations. So not just one, but sometimes two. It could be a rotation in translation, it could be a reflection in translation. They have a visual on what these would look like and are able to see exactly what they would be practicing. In example 2, also would be teacher-led, where we have some translations shown, we have a dilation and a reflection shown together. And so students will be walked through these examples by the instructor. And also we have a reflection both of a square and a triangle. So these are some of the examples that the students will have in addition to what was mentioned previously. For the formative assessments, students will have an opportunity to work as groups. So after the instructor has done their part, then students will get to do what we call a we do, where they work together in groups to collaborate with each other, to learn from each other. And so they have the opportunity to work on these 2 task cards. So the first task is really to find the center of rotation. So that's something that they can do themselves, or they can work together with their groups, discuss what they think the center of rotation is, because it's not necessarily obvious. And so they can work together there. There's also a second task card that students are able to use. Here you have a list of instructions and the 2 task cards, problem card number 1 and problem card number 2. Students can develop their own sequence of transformations, so they could initiate, or the teacher could also provide instruction as to which transformations they could do. They can discuss their findings as a class, they can present, they can do a number of things to show if they are understanding the content well. And then they can work individually with these. They can identify the transformation shown. There are different options, not just your translation, but they also have an opportunity to practice doing that translation, to practice rotation, whether they're using the rules or they're using GeoGebra directly, and also a reflection over the X and y-axis along with a rotation, and also a rotation and a reflection over the y-axis. So these are the same, these 2, but they're in different order. And what this does, it allows the students to figure out, well, are my transformations, does the order matter? So if I do a reflection, then a rotation, does it matter if I do the rotation and then a reflection, since it's a congruence transformation, or they both are? And so they can investigate this and see for themselves if this is something that matters, and that will help them if they're working on problems to see if they can select one that's simpler to them versus another one. And this is a second example where they can do, this time not a rotation, but a translation with a reflection. And again, it's in 2 different orders, and they'll be able to discuss the findings either with the class or, within their groups. And then they can figure out how well they're understanding the content. And then I will move on to the summative assessments. This is where they get to show what they know. So they get to tell the teacher with their work where they, at this point, would not have an opportunity to get help. Before, when they're doing their formative assessments, they have this opportunity. But now for the summative assessment, they now have to show what they know as an individual, not as a group, or not with the help from the teacher or the instructor. So we have different ways that they can show this. It's directly pointed out, whether they can graph it themselves. They have the option to put in the coordinates, as you see here in 2B. They have the opportunity to take notes, so to write down exactly what they think in this notes section. So there are different ways that they're assessed, that they can demonstrate mastery of the content. And this would do it. They also have a multiple choice option as well. So different ways that they can show what they know. And so if they're engaging with the content well, if they're paying attention, if they're practicing, if they're using all the resources that are given to them, then they will be able to gain all the skills that were outlined in the objectives. And next, you'll see a few references that were used in order to develop this GeoGebra book for the group project. Thank you, guys.